introduced the Wittig reaction in the last video, and I'd like to just take a little bit more detailed look at it. All right, let's run through the way in which the reaction takes place. So we start off with some sort of a carbonyl. I'm going to show it as a ketone. And we'll label these alkyl groups just to keep everything straight. Okay, this is 1 and 2. All right. And basically what we do is we react it with the Wittig reagent, okay, which we'll call R3. This doesn't mean 3 alkyl groups, okay? It's just sort of like an indexing of one of them. All right, and we have this. Okay, so this is the Wittig reagent. We'll show how you do that in a minute, okay, because I just want to show you what the overall effect of the reaction is. So what's going to happen is that ultimately we're going to hook up this negatively charged carbon in the Wittig reagent to the carbonyl over here, right? Incidentally, I should put a positive charge here, okay? This is what's known as an ylid, okay? Okay, that's an ylid. Okay, it means that you've got a positive and negative charge directly adjacent to each other. All right. Okay, and what's going to happen now is that, we'll go through the mechanism in a minute, but I just want to give you an overall picture of what takes place. So what happens in these Wittig reagents is essentially you replace the carbon-oxygen double bond with a carbon-carbon double bond. So this carbon now is going to be doubly bonded to this carbon. And that's what makes this reaction so useful, because it enables you to precisely place a carbon-carbon double bond. And if you recall from last semester, if any of you do, all right, remember that the other way that we have of making carbon-carbon double bonds is by elimination reactions, E2 reactions, and sometimes that's a problem because you don't know which side of the carbon you're going to have the double bond forming on, all right? So with this, it's very precise, okay? All right, now the way the reaction proceeds, first of all, you have to make the Wittig reagent, all right? 1, make. Okay, so we start off with this compound, triphenylphosphine. Okay, and these phenyl groups, they're, oh, I'm sorry, I'm stepping out of the line here. These are benzene rings, okay? That's the abbreviation for a benzene ring. This is a good nucleophile, but this is a big, clunky molecule. So it's a good nucleophile up to a point, all right? Because what's going to happen is that the steric interactions here, it's so big that it's limited in its ability, but it's strong in the sense that the phosphorus has a lot of polarizability and it can act effectively as a nucleophile. All right, so we're going to take, in this case, we'll use a primary alkyl halide. Okay, this is 1-bromopropane. Okay, so the phosphorus comes in, boots out the bromine as a bromide ion, and we get this. I'm going to abbreviate this. Okay. Wait a minute. Yeah. Okay, and we got a positive charge on the phosphorus. Okay, now ultimately what we want to do is, in order to make this reaction work, we've got to get a negative charge on this carbon here. This carbon that's directly attached to the phosphorus, so that it can act as a nucleophile. Obviously, that's not the case here, all right? And this whole thing is not nucleophilic, okay? It's got a positive charge. So what we've got to do, we can't actually get rid of the positive charge on the phosphorus, but what we can do is we can sort of minimize its effect, okay? We can neutralize it if we can pull a proton off here, all right? If we pull a proton off this carbon here, the carbon will take on a negative charge and we will get this, all right? So okay, and you have to use a fairly strong base for this. You can use hydride, you can use sodium hydride. The one that I'm going to use here is going to be N-butyl lithium. All right, plus, all right. Okay, this is N-butyl lithium. This is an extremely powerful base. All right, so what happens is it comes in, pulls off this proton, and we now have this. Okay, and this is our Wittig reagent. Okay, now we're all set to go with the second step of the reaction, where we take this and we mix it up with our carbonyl compound. Illid reagent. Okay, this looks like this. Okay, now we add it to our carbonyl compound. Let's just use an aldehyde here just for simplicity. Okay, so what's going to happen is that this is going to come around, it's going to hit carbonyl, okay? And we're going to get this little intermediate. Now this is tough to draw. Okay, all right, so we're going to have okay, so this portion here came from the, let me just draw a dotted line through here. Okay, these are the two things that come together. Okay, so remember this was that negatively charged carbon that in the Wittig reagent. Okay, that's this guy here. All right, and that hooks up to the carbonyl in the aldehyde. Okay, so we get this little intermediate here. Okay, well. Now what happens is that we get some shuffling of electrons, as you would expect. Okay, so what's going to happen is that this bond between the oxygen and the phosphorus is going to be strengthened by this. Okay, so we're going to have a pair of electrons coming out of this bond here. This is the remnants of this carbon-oxygen double bond. All right, and then at the same time, we're going to have a pair of electrons coming out of this bond here, because this whole thing is going to break away. All right, okay. Okay, we end up with that. Okay, so that's the way the Wittig reaction works, and that's the product of the reaction. Okay.